Hello everyone, welcome back. Now we are in a position to discuss a new sensor, that is the PCA9536 with a buzzer. Now to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this particular sensor, and let's see what we got here for this particular sensor, that is PCA9536 I2C Digital 3-channel input output with a buzzer, and it's a I2C controlled buzzer, and you can see more prominent features of this particular sensor, and you can also have the privilege to add to cart or to purchase the sensor right from this website, right from here. Alright, now I'm going to interface the PCA9536 sensor with a buzzer, and the platform will be BeagleBone Black, and the software platform will be the C code language. And to get your hands on the code, let's go to resource tab, and here we have the C code sample onto your screen, and you can download the code sample as a zip file right from here. And you can also have the code from github.com, and the concerned repository there is Control Everything Community. Now we want to do some connections for the hardware, and let's see what we got there. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Next, we need our sensor, that is PCA9536, along with a buzzer. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the ground terminal of the I2C Shield. Now we are done with all the connections for the hardware. Now let's have a look over the code, and let's see what we got there. Well, now let's have a look over the interfacing code, and to get your hands on the code, we have to first of all log into github.com, and then we have to search on for the repository, that is Control Everything Community. And after that we have the sensor, as you can know, PCA9536 with a buzzer. Now let's proceed with the C code, but before that, let's have a look over the working instructions for this C code. First of all, we need to set up our BeagleBone Black, as you notice, and the BeagleBone.org is the official link from where we need to install all the required drivers, and everything need to be set up from right here, just like that. And then we need to download or get pull the code onto the BeagleBone Black, and then this command will set the compilation of the C code, and this will build or run the code. Please note them down carefully, which we will need later in the working part. And then we have the C code, as you notice, it's a C file. And in the code, first thing you notice that we have included some of the libraries, header files, and the void main function. We have to check whether the I2C bus is open or not. Then we have to check for the I2C device whether it is connected, and the address of the sensor is 0x41. Then in the writing section part, first of all, we need, as you notice onto my screen, we have to select the configuration register 0x03, and we are going to write 0xF0 as output. All pins are configured as output. Then we have to read some data from this very register, as you notice onto my screen, and here we are going to print some data onto the screen. We are going to read the data from the register, that is 0x01, whether it's logic high on each pin. It is going to be set here, just like that here. And in this part, we have a if else condition, which will check whether input output pin state is high and buzzer is off, or whether input output pin state is high and buzzer is on. So there is a if else condition, which you are good with that. Now what we're gonna do is to show the working of this C code along with the BeagleBone Black and the sensor. Let's have it. Now coming to the working section, which is really important as it provides the practicality of the code. and for that, first of all, copy the entire code of C language and copy it and open up the terminal. For the BeagleBone Black we have connected through the internet, and here we have, first of all, as you know, we have to create a new file, and it's a PCA9536 Buzzer .c will be the extension, and here we have to paste the entire code, and after pasting we have to save it. Now, as you know, this is the command for the compilation of the code, and let me complete it, and here we are, and the code is now being compiled. It's done. Now to build or run the code, this is the command as we know, and let's see what we got here. And when I run it, and when I again run it, we have the output. As you see from the previous commands regarding the running command, we have seen that input output pin 0, 1, 2 state is high and the buzzer is off. But whenever we go to input pin 3 and the state is high, the buzzer is on. So this is how the sensor works. Now what we're going to do is to show the applications and some of the benefits regarding this sensor. The PCA9536 is an 8-pin CMOS device that provides 4 bits of general purpose parallel input-output, that is GPIO expansion for I2C-bus, SMBus applications, and input-output expanders provide a simple solution when additional input-output is needed for applications like ACPI power switches, sensors, push buttons, LEDs, fans, etc. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubts regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.